Ever wondered how a bike could ride completely on its own? No rider, no hands on the handlebar, yet it balances, steers, and even navigates the road. Self-driving bikes may sound futuristic, but engineers have already built them. In this video, we'll break down how they actually work, step by step. We'll see how the bike detects balance, how it corrects itself, how it steers, how it sees the road, and how some designs even stay upright when they stop. Let's start with the biggest challenge. 1. The biggest problem. Balance. Unlike cars, bikes are not naturally stable. A car has four wheels and can stand still easily. But a bike constantly needs balance corrections. When you ride a bike, your brain automatically makes tiny steering adjustments every second to keep it upright. A self-driving bike has to recreate those same corrections using sensors and control systems. 2. How the bike knows. It's leaning. To detect balance, the bike uses a sensor module called an IMU. IMU stands for Inertial Measurement Unit. Inside this small device are two important sensors: an accelerometer, which senses gravity and tells the bike which way it's leaning, and a gyroscope, which detects how fast the bike is rotating. Together, these sensors constantly measure the bike's position and movement. Even a tiny tilt can be detected instantly. 3. The brain of the bike. Once the sensors detect a tilt, the data goes to a controller. This is basically a small onboard computer. The controller calculates how much correction is needed to bring the bike back into balance. Too little correction, and the bike falls. Too much correction, and it becomes unstable. So the system constantly calculates the exact steering adjustment needed. And it does this many times every second. 4. How the bike steers itself. But calculations alone can't move the bike. Something needs to physically turn the handlebars. Most self-driving bikes use a small electric motor connected to the steering mechanism. When the controller sends a signal, the motor turns the handle slightly left or right. These tiny steering corrections move the wheels under the bike's center of mass, and that helps the bike regain balance. 5. How the bike sees the road. Balancing is only part of the challenge. The bike also needs to understand its surroundings. For this, engineers use cameras and sensors. Cameras capture images of the road ahead. The onboard computer processes these images to detect lanes, obstacles, and direction. Some systems also use LiDAR, or ultrasonic sensors, to measure distance from nearby objects. Together, these sensors allow the bike to navigate safely. 6. How the bike stays upright. When it stops stopping is one of the hardest problems. When humans stop a bike, we simply put a foot on the ground. A self-driving bike can't do that. Some designs keep balancing with tiny steering corrections, even at very low speeds. Others use balancing systems like internal flywheels or small support wheels. These mechanisms help the bike stay upright even when it's not moving. Conclusion: so a self-driving bike isn't magic. It's sensors, computation, and precise mechanical control working together in real time. Basically, the system replaces the tiny balance corrections your brain normally makes while riding. And that's how a bike can ride, all by itself,